Welcome, everyone. My name is Steve Lang, and I am talking to you from the Canadian Space Resource Center, which is at Mark Garneau Collegiate. The Canadian Space Resource Center is part of the TDSB's Leadership, Learning, and School Improvement Department. Today's episode, we are going to be studying space, and we're going to be looking at the planets. We're going to take a voyage to the planet. So let me switch over and begin the presentation.
All our eyes focus on two now. Stage 2 hospital response after hospitals are complete.
Just wait 1 or 2 more minutes for a few more people to join, and we will begin shortly.
Stage 2 launch load complete. All fuel, all oxidizer on Falcon 9. 1 minute 34 seconds to go till launch.
Back end will be starting.
Falcon 9 is in startup. Ready to be captain. SPS is armed for launch. Under a minute now. SPS, the flight testing system has been armed. Great, SpaceX, go for launch. SpaceX Dragon, let's go for launch. Let's like this stand up.
T-minus 30 seconds.
Stage 1 tanks pressing for fully.
T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff of the Falcon 9 Crew Dragon. Good network. Good SpaceX. Godspeed. Spot is done.
No rise on the new era of American spaceflight. The new generation continuing to train. 20 seconds into flight stage on propulsion is phenomenal. Flying through my motor taken and Falcon 9 and Royal Hill. Falcon 9.
So, once again, thank you for joining me. My name is Steve Lang, and this is the Canadian Space Resource Center at Mark Garneau Collegiate. So, as always, we begin every session with the land acknowledgement.
We begin each day by acknowledging the land upon which we live and work. Please stand as you are able for the land acknowledgement, followed by O Canada. We acknowledge we are hosted on the lands of the Mississaugas of the Anishinaabe, the Haudenosaunee Confederacy, and the Wendat. We also recognize the enduring presence of all First Nations, Métis, and Inuit peoples.
So today's episode is called A Voyage to the Planets. Now, throughout the episodes, I will have questions. Obviously, you can't answer them to me, but if you can, just amongst yourselves or in your own space, just see if you can find the answers. So my first question to everyone is, what is this an image of? So, of course, we live in a galaxy. The name of our galaxy is the Milky Way. It is filled with hundreds of billions of stars. Now, these stars are kind of configured in arms. That's why we call it a spiral galaxy. These arms are spiraling outwards, and we live on one of the arms, which we have named. Does anyone want to guess which arm we live in? So if you guessed the Orion arm, we're right about there, you would be correct. And what we're going to talk about today, just to give you an idea of how big our galaxy is, how big space is, you can't even see what we're talking about today. It's smaller than that little dot that I'm pointing to right there. And that, of course, is our galactic neighborhood, and that is the solar system. So, how many planets do we have in the solar system? Now, some students tell me 9. There used to be, but of course, the official answer is 8. And this is a great picture showing the different sizes of the planets. Now, they don't normally line up like this, they only do that typically for the photograph. But you can see in this image that the inner planets are much smaller than the outer planets. So let's start with those. So those outer planets, we also call them gas giants. And those, of course, are Jupiter, Uranus, Saturn, and Neptune. Now, I've included Pluto. And it's not because it's a planet. It's not. We'll talk about what it is. But it's because it's still there. A lot of people think that something happened. Well, we just reclassified Pluto, but it's still out in space orbiting around. Then, of course, we have the inner planets, and these are the smaller, also called rocky or terrestrial planets. We have Mercury, Venus, Earth, and Mars. And of course, we live on the third planet from the sun, and that is Earth. Now, all of the planets are moving around in space in this really big oval that we call an orbit. And at the same time that all the planets are orbiting around the center of the sun, we also have all the planets moving in another way, and that is got a couple of different names. We either call that rotation or spin. And they do this on an imaginary line that we call an axis. So the blue line you see there is an imaginary line, and you can see the direction of rotation or spin based on those blue arrows at the top. Now, there are 2 planets that are different. And if you look really carefully at the arrows, you might be able to figure out which 2 planets they are. They happen to be Venus and Uranus, which are spinning backwards from all the other planets. So there's a lot of different movement throughout the solar system. We have the planets orbiting around and spinning. So let's take a look at those planets. And I know a lot of people know the planets, but sometimes when I'm talking to students, the order of the planets gets a little confusing. So there's lots of ways you can remember the order of the planets. This is the way I do it. I use a saying, which is, my very educated mother just served us nachos. And as you can see, the first letter is in red because that will remind us what is the order of the planets. We have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And as always, we start at the center, which is where the sun is, and we move outwards. So that first planet, which starts with M for my, is Mercury. And here's an image of it. Mercury is the smallest planet. It is a rocky terrestrial planet. And a lot of people ask about that swath, that blurry part. Well, the truth is, we've had spacecraft in orbit without people on it that are orbiting Mercury. And they take images, high resolution pictures of the surface of Mercury. This one is one in which we haven't finished all of the pictures because they take a bunch of them and like a puzzle, they put them together and they just haven't finished getting all the images yet. So remember those movements we talked about? Well, the two movements we call a day is the smaller rotation, and of course the big orbiting is called a year. So 1 day on Mercury is equal to about 59 Earth days, and a year is about 88 Earth days. So 2 months and 3 months for the day and the year. Now, do you think that Mercury has any moons? And if it does, how many do you think it has? Well, Mercury doesn't have any moons. There you can see its surface. So it's one of the few planets that does not have any moons. Now, do you think Mercury has an atmosphere? So before I go on with that, let me just explain. On Earth, we have the planet surrounded by this stuff. That's what we call an atmosphere. Now, a lot of people just call it air, but another name for it is an atmosphere, and it's made of gas. And the gas for us on Earth is that air, as we call it, is nitrogen, oxygen, some other gases. So when I ask the question, does a planet have an atmosphere? Well, clearly ours does. We call it air, but it doesn't mean that the other planets have to have exactly the same kind of atmosphere. If they have some sort of gas on the surface, then that could be considered an atmosphere. So when I ask the question, does Mercury have an atmosphere? What do you think? Remember, it doesn't have to be the same as ours. The answer is yes, it does. And it's really odd because it's very small. It's constantly changing. You can see it there with the yellow that's been highlighted. The gas is hydrogen, and it comes from the sun. So the sun is a big ball of gas, hydrogen gas. And so some of that gas escapes and ends up on the surface of Mercury, but it's constantly changing. So another name for this is an exosphere. But technically, it's a very small and odd kind of atmosphere, but it does have one. And being a rock, it's the smallest planet, it's terrestrial. Well, everything has gravity. And even the smallest planet, like Mercury, has gravity. There are rocks flying through space. And sometimes they get too close to a planet, like Mercury, and the planet's gravity pulls it in, and there's a collision. And now these rocks are moving at thousands of kilometers per hour, and so they leave these indentations all over the surface. We call them craters or basins. And here is some mountains on Mercury. Now I have another question for you. Do you think Mercury is hot or cold? Another option is, could it be both at the same time? Now think about it. Mercury is the closest planet to our sun. So a lot of people think that it's really hot, and they're half right, because remember back to what I said with its rotation, its day. It's spinning very slowly. It takes almost 2 months of Earth time for the planet to spin, which means that the side facing the sun does get very, very hot, but the other side, which is for a long time in the shadow, excuse me, gets very, very cold. So it's actually both hot and cold at the same time. And there's a great picture through a different wavelength of light to show the surface of Mercury. So what planet starts with a V? And that would, of course, be Venus. Now, Venus is rather strange. Why? Because of its orbit and its rotation. So we're used to having a day that's much shorter than our year. But on Venus, its day is much longer, 243 Earth days for its day, but its orbit, it's closer in than us, is shorter at 225. Now, do you think Venus has any moons? And if it does, how many? What do you think? Here's a picture of it. And the answer is no, it does not. Now, do you think Venus has an atmosphere? Remember, an atmosphere doesn't have to be exactly the same as ours. And of course, the answer is yes, there it is. It's surrounded in these clouds that have gas in them. So that's what Venus looks like without all those clouds. And sometimes you'll find an old book or somewhere on the internet that says that Venus and Earth are sister planets. They're similar. Well, they have some similarities. They are about the same size. And when you measure things in space, they're really not that different in their distance from the sun. The one's a little bit closer. After that, they are nothing alike. So those clouds that we showed you on Venus, well, one of the things they do is they trap the heat. So they actually make Venus the hottest planet in the solar system. Now, up at the upper parts of the clouds, it's not so hot, but down below where the sun gets trapped, it's very, very hot. They are trapping the heat from the sun, making it about 500 degrees Celsius. Now, those clouds do a few other things that we wouldn't like. Besides trapping the heat, they add pressure. Now, we have pressure from our atmosphere, but we don't notice it because it's normal. If it changes, if it goes up or gets less or gets more, we notice it. If you've ever been in an airplane and your ears pop, that's the pressure getting less. Well, on this planet, those clouds squeeze things that are on the surface, and the pressure would be 90 times what you're feeling right now. And then on top of that, well, those clouds also have something very similar to sulfuric acid in them. That means it can melt things, even heavy metal things. And so if you try to land on the surface, and we've actually done that with a robot, well, the Russians did back in the 80s. Here's an image, one of the only ones we have of the surface of Venus. And you can see the yellow in the distance. Those are those clouds. And so this spacecraft, after many, many attempts, they finally got a spacecraft to land and operate. It started to send back these amazing pictures. And then after 2 hours, it stopped. And it's not a big shock because, again, it's 500 degrees, so it's being baked. It's being squished by 90 times the pressure. And then those clouds are probably melting other parts of the spacecraft. So my very educated well, of course, that is our planet. And I'm sure everyone knows how long is a day and a year on Earth. Well, we round these numbers up and down. We have approximately 24 hours for a day and about 365 Earth days for a year. And I know you know a lot about Earth, so I'm not going to say much other than Earth is the only planet we have found any kind of life. We've been looking, we think that we've found a few clues that it's maybe possible that we'll find life elsewhere, but we have not found it yet. Earth is the only place. And of course, I also know that we have one moon with probably the most uninteresting name ever, the moon. Even in other languages, which sound a bit nicer to us in English, you're still saying the moon. And I want to point out that this is as far as humans have traveled. We have sent, and you've already seen some and you'll see more, that robots have gone out and explored, but people have only gone as far as the moon. There's a shot on the left of the Earth and the moon. And then on the right, you're seeing a picture from one of those astronauts when they were circling around the moon. That's the gray thing on the right. And you saw the Earth in the distance. So my very educated mother, what planet starts with another planet that starts with M? And that, of course, is the red planet Mars. Now, its day is very similar to ours at a little over 24 hours, but it's further out from the sun, so its orbit, unlike the other planets we've talked about, is now getting longer. So it's a little bit less than 2 Earth years at 687 Earth days. Now, do you think Mars has any moons? And if you do, how many? The answer is it does. Mars has 2 moons, Phobos and Deimos, and they're rather odd. Our moon, we have one, and although it's small, it's still much bigger than these two. It orbits the Earth at 400,000 kilometers away. These two are really more like asteroids. There is an asteroid belt near Mars, so they're more like asteroids because these 2 moons are very small. Phobos, being the bigger one, is only 22 kilometers wide, and Deimos is 13, and they orbit Mars really close to the surface, Again, Phobos is only 6,000 kilometers above the surface, and Deimos is 23,000. Again, compared to Earth at 400,000, these are much, much closer. So, do you think Mars has an atmosphere? Remember, it doesn't have to be like air, it could be another gas. And it does, and it's deadly to us. That gas is CO2. It's what we breathe out, carbon dioxide. And the other issue is that even if it was air, it is very thin compared to Earth. It's only 1% of what we have here on Earth. So even if it was air, something that we could breathe, there wouldn't be enough of it if we ever wanted to explore Mars. But we have explored Mars with robots, and we've had them circling or orbiting the planet, as well as driving around and landing on the planet. And we found that Mars has some of the coolest features in our solar system. It has the largest mountain in our solar system. Here it is, Olympus Mons, which is 3 times taller than Mount Everest. And of course, being triangular shaped, it is very big at the base. It's about 550 kilometers across, which, if you look at a map, would almost fill the country of France. Now, there's a big canyon, if you want to call it a scar, right across the surface of Mars. We call this Valles Marineris. And as the robots that we've sent there approach, you can even see this scar from space. And it is pretty long. For us, we would say that it would stretch from one side of Canada all the way across to the other. It's about 4,000 kilometers long. Now, humans have not gone there, but we have sent lots of robots over the years. There are just 3 of the rovers that have been on Mars. We started off very small with the Sojourner robot just to see if we could do it. And then NASA sent 2 identical rovers, Spirit and Opportunity. These were the middle ones. They're about the size of a kitchen table. And then today, we actually have 2 more robots that are still working. The first 2 are not, but the 2 that are, Curiosity and Perseverance. This one is Curiosity, and Perseverance looks very similar. They are about the size of a small car, and they're currently on Mars exploring. And one of the things they do, well, they, of course, can take selfies, but they're there really to look for evidence of past life. So one of the questions, of course, is, are we alone? Is there life elsewhere in space? And trying to look for it is not easy. So we're looking at the closest place that we can get to that we can survive on with robots, and that is Mars. And here's a real picture of Mars with Marvin the Martian added in. So clearly, if there is or was life on Mars, it's not just right there. We can't see trees or plants or animal tracks or even animals. So one of the things that we've realized is that all life that we know of requires water. So we decided, let's start to look for water, and that'll help us narrow down where do we go and look for life. So one of the robots we have orbiting around Mars was looking for water. And here's a map, and all the blue stuff on Mars or on there is water. So that's all the water on Mars right now. Now, Mars looks like a desert, but Mars is actually very cold. The average temperature is minus 60 degrees Celsius, pretty cold. So that water that is there is frozen, either on the surface or underneath. Now, Mars has seasons like we do, and so occasionally, at the right time of year, it does warm up to a balmy about 10 degrees Celsius, warm enough for the water to melt, the ice to melt to water and flow. And here we're seeing 2 areas on Mars photographed, one or more in the wintertime and one in the summer, and you're seeing that that water has moved. Now, some of the things that the robots have found on Mars is that Mars, millions, if not billions of years ago, used to be a lot more like Earth. In fact, it was covered in water, and that water was flowing, much like our oceans and rivers and streams do here on Earth, which means that at one point, Mars was also a lot warmer. And that's why, when we've gone there with the Perseverance rover, we have chosen to land where we have, which is a place called Jezero Crater, which a long time ago was Jezero Lake. So the image on the right shows you some of that crater, and the white circle is showing you where they landed. And the reason they chose that is, if you look, it's a close-up picture on the left with the color. Well, that area there, billions of years ago, was a river that was flowing water into Jezero Lake. And as happens on Earth as well, the water flows, and of course, mud and silt and dirt get pulled up into that as it's flowing. Now, if there was water, and that's where we think life would exist, there's a good chance that while it was flowing and dumping its dirt here into Jezero Lake, of course, all of this would have been underwater. Some of that life would have been trapped and then in the mud and stayed there. Now, of course, the water is all gone, and what's left over is this green stuff. And that is where we're going to look. So the robot landed in the white circle, and Perseverance is going to be driving and on its way drilling down into the mud looking for evidence of life. And that green area indicates carbonate materials or minerals. And this happens on Earth as well. So the life, if it gets trapped in there, and then when things dry up, evidence is trapped in these carbonate minerals, and that's a great place to look and drill down. So that's what Perseverance is planning on doing. So we're now gone from the inner planets to the first of the gas giants and the biggest planet. And this one, of course, is Jupiter. And yes, Jupiter does have rings. You can see them there. The rings are made of rock and dust. And because of the reflection of the rock, it doesn't reflect light in quite the same way as ice does. We'll talk about that in a second. So the rings of Jupiter are much harder to see. So its day is typical for a gas giant, about 10 Earth hours. But when we look at its year, we can see that the orbits have gone from on Earth 1 year to Mars a little less than 2 years to a huge gap of 12 Earth years. Now, do you think Jupiter has any moons? And if so, how many? So the answer is it does. It has a lot of them, 79. I talked about our moon having a rather uninteresting name of the moon. Look at these names right here: Io, Europa, Ganymede, Callisto. And we've been looking at some of these moons because it's very interesting. We've flown robots past, and when we did, like in the case of Europa, we noticed something was spewing out. There was some vapor coming out, and we analyzed it, and it turns out to be water vapor. So what we believe is that on this moon, there is water on the surface, and underneath the water, the center is heated up, kind of like the Earth's core is heated, and that's making the water warm. Well, being exposed to the vacuum of space and the coldness of space, it's frozen. We have about a layer of about 400 kilometers of ice, but that warm water occasionally melts through and blasts into space. We think there's as much water on this tiny moon as we have in all of North America. You think about that. We have the Great Lakes, we have rivers and streams, all the lakes in the United States. It's a lot of water on this one tiny moon. And the combination of heat and water would be a great place to look for life. We just have to figure out how to drill through that 400-kilometer crust of ice. Now, there are other moons of Saturn and Jupiter that have water. So maybe if it's easier, we'll go to one of those. Now, do you think Jupiter has an atmosphere? Now, let's remember that an atmosphere is gas. And what we're talking about now is a gas giant. So the answer is yes, it does. And like all the other planets but Earth, it is deadly to humans. The gases, hydrogen and helium and methane. And there you can see those colored bands or some of those gases swirling around at hundreds of kilometers per hour. And see that spot right there? Well, that's called the Great Red Spot. And we've been watching that for hundreds of years. I believe it was 1609 that Galileo first pointed the telescope up into space. And one of the things that he was able to see was this Great Red Spot. And back then, it was to show you how big this planet is, that red spot alone was about the size of 2.5 to 3 Earths. Now, the planet hasn't changed, excuse me, but the storm, which is swirling around in a circle, has. And over the last few years, it's actually gotten a fair bit smaller. It's now about the size of 1 Earth. And the speed is increased to something around 640 kilometers per hour as it spins around. So my very educated mother just served. So S. And that planet, of course, is Saturn. And a lot of people think Saturn and they think rings. And as we've learned, it's not the only one with rings. We'll talk a little bit more about why we can see the rings so easily. But its day is not that much different. It's almost 11 hours. Its year, again, quite a bit further out at an orbit of 29 Earth years. Now, do you think Saturn has any moons? And if so, how many? Well, it has 82 moons, the most moons of any planet in our solar system. And the biggest of those moons is Titan. And we've actually landed on Titan. At least the Europeans have sent a robot in 2005, the Cassini-Huygens spacecraft. With the Huygens was the smaller one that detached and went down through the atmosphere. You see this animation or diagram in the upper left. On a parachute, it floated down, and while it was floating down, it discovered that Titan has clouds and rain and lakes and rivers of liquid hydrocarbons, as well as a subsurface ocean of salty water. You can see a few images there of the mountains. And then when it landed, it was quite a shock because it landed on what appeared to be a shallow lake or river. And there you can see these are real images from the surface of Titan. This is the furthest away any spacecraft has landed on the surface of another body other than our moon. So, do you think Saturn has an atmosphere? And of course, again, this is a gas giant. And so, yes, and much like Jupiter, it is deadly to humans. Now, here's a great shot of those rings. And originally we thought that the rings were one solid ring because, of course, from Earth, that's how they appear. But Saturn actually has 3 main rings with 5 smaller dusty rings for a total of 8. And there's gaps in between. So depending on how you count them, some people will say that there are 9 rings. And there they are. And again, you can see a great gap. And if we could get up close, you would actually see that these rings are made up of rock and, importantly, ice. The ice is important because ice, as we've discovered over the last few days, is reflective, right? So planets don't give off light. They reflect light from our star, the sun. So if an object, a planet or a moon or rings, doesn't reflect much light, it's very hard to see. These rings have lots of ice, and the angle that we're seeing them is a way that we can see them very easily. It's not, you're looking at the widest part, so it's easy to see, and they're reflecting a lot of light. And the strange thing about Saturn is it is a gas, it's very light, and if we could actually find a pool or an ocean or body of water big enough, it would actually float in water. Now, the next planet. My very educated mother just served us. And this is the one that's mispronounced, of course, and it's pronounced Uranus. And it's odd because, again, we said, like Venus, it is spinning backwards from all the rest. It has rings as well, and those rings are almost straight up and down, spinning backwards. So it's got the longest day of any of the gas giants. It's 17 Earth hours. And its year, again, quite a bit further out at 84 Earth years. Now, do you think, excuse me, does Uranus have any moons? And if so, how many? It does. It actually has 27 moons. And one of the things that's interesting is that these moons are named after the works of William Shakespeare and an English poet named Alexander Pope. And so here's a few of them here. From left to right, we have Puck, Miranda, Ariel, Umbrel, Titania, and Oberon. And if you study any of the plays of Shakespeare, some of those names will be familiar to you. Now, do you think Uranus has an atmosphere? And again, this should be pretty simple because we remember that they are a gas giant. The gas, mostly hydrogen, but also a lot of helium, which methane, which is giving it the blue color. So it is deadly to humans. So remember, the two planets that are spinning backwards are Venus and Uranus. Now, the last one is Neptune, and again, a big ball of gas. And its day is average for a gas giant. It's 16 Earth hours. Its year is 165 Earth years. Does it have any moons? It does. We haven't sent a lot of spacecraft out there, and so although we know about them, some of them are harder to see. One of them we only discovered in 2019 because again, some of these things are small, close to the planet, and if they're made of rock, they don't reflect a lot of light. So it has 14 known moons, and being a gas giant, we know that it has an atmosphere which, as usual, is deadly to humans. Another cool feature is you see that spot right there? Well, that's called the Great Dark Spot. And again, like this spot on Jupiter, it is a storm, but it also, when we went past it with our robots, saw another one. This one was called, one of the names was called Scooter because it was scooting around the planet. Both of those are both gone. We can't find them anymore, so the storms may have blown out. But to give you an idea of how big they are, the storm, the Great Dark Spot, is about 7,000 kilometers across in size. So I said I would talk a little bit about Pluto. So Pluto is not a planet, but I do like to talk about it. It's still orbiting the Earth. It's still spinning and rotating. So its day is a little bit less than a week, and its orbit is huge at 248 Earth years. Now, do you think Pluto has any moons? So for the longest time, we knew that Pluto had one moon. And what was odd about it was its moon, Charon, relative to its size, they were both very close in size, which is odd. As we've seen, a lot of the moons are much, much smaller than their planets, because back then Pluto was a planet. In 2005, before we demoted Pluto, we found that it had 4 more smaller moons, so it has 5 moons. Now, do you think Pluto has an atmosphere? I'm not going to answer that just yet. I'll explain in a minute. So let me explain what happened to Pluto. So a long time ago, back in before the 1930s, we thought there should be another planet out there, and a gentleman, an astronomer named Clyde Tombaugh, started to look for it. It took him a year, and he finally found an object that, because they assumed they were looking for a planet, they just called it a planet. And you'll see the images they had weren't very clear. So we didn't know a lot about Pluto, but we did know it was small. And a lot of students tell me that Pluto isn't a planet because of its orbit. Now, we measure everything from Earth. So we are kind of the standard, and everything is measured compared to that. So most planets are slightly on an angle to us. Pluto is off at 17 degrees. Now, in the 1990s, as our technology was getting better, Pluto was still a planet. We started looking for planet 10 or planet X. And what we discovered was that about 7 billion kilometers out in space where Pluto is, we had a ring of rock and ice and dust and stuff called the Kuiper Belt. And people started to discover some things in the Kuiper Belt, things like Sedna. That's that little white dot in the red square. Or things like Eris, which is the little circled white dot, also called the UB313. Okay, to give you an idea, its orbit is about 10 billion kilometers away from us. So these objects, people thought, should be called planets. The trick was that the astronomers who actually get to name these things and tell you what a planet is could not agree on what a planet was. So they finally realized, as we're finding more of this stuff, we're going to have to start figuring out exactly what a planet is. and come up to with one definition. So they had a big conference, a week-long conference, where they discussed a lot of things, including finally coming up with what is a planet. So here it is. A planet has to orbit around a star or our sun. Number 2 says all planets have gravity that makes them round. So that's number 2. Number 4, we've talked about moons. Another name for moons is satellites. So moons or satellites are not planets. And number 3 is the one they kind of argued about. They said in the billions of years that this object has been orbiting around, well, if it's the biggest thing, it'll have the most gravity, which means it'll pull all the smaller stuff in and will clear the neighborhood around its orbit. So that's what number 3 says, that the object, which we call a planet, has cleared, because of gravity, the neighborhood around its orbit. So immediately, once they agreed on this, it meant that Pluto, out in the Kuiper Belt, which has not cleared its neighborhood, wouldn't be counted. And I guess they figured they couldn't leave the meeting without reclassifying Pluto. So being smart people, I think what they did was they said, here's what we're going to do. We're going to add 2 words to this definition. We're going to add the word dwarf and the word not to number 3 and say that anything that has not cleared the neighborhood around its orbit can be classified as a dwarf planet. So right now we have 5 dwarf planets. The moon is just there to show us the different sizes. We've got Pluto, of course, is the most famous. We have Eris, Ceres, Makemake, and Haumea. Show you where they are. The closest one, just past Mars in that asteroid belt, is Ceres, and the rest are out around Pluto in the Kuiper Belt. So there's the first one we ever went to. That was Ceres. No, we don't know what those bright things are. It's probably some reflective surface, like a certain kind of rock that is very reflective. We weren't able to go back and look at it, so unfortunately, we'll just have to take some educated guesses. But going back to Pluto for a second, here are some images of Pluto, and the one in the upper left is the one I want you to look at, because that's the one that Clyde Tombaugh used to find Pluto. Not very clear. And even with telescopes in orbit around Earth, like the Hubble Space Telescope, we weren't able to get really clear pictures of Pluto. It's really small, it's really far away. So it wasn't until we sent a robot from Earth to Pluto, took 9.5 years to get there, that we finally were able to get clear pictures of Pluto. So we went from this to this with the New Horizons spacecraft. And that's when we first started to get some really good information and good data about Pluto. Things like it's a frozen ball of ice and rock. And to answer our question, yes, Pluto does have a very thin atmosphere of methane, which of course is deadly to humans. So Pluto is small, as we've always suspected, and now we know exactly how big it is. It is about the size of Australia. So that is a bit of a voyage through our planets. There we are in our solar system. And of course, we know that there are other things out there. This is what we look like from Mars. Some of those robots on Mars are able to look back at us just like we look up at the other planets. And this is a great image here coming up. This image I'm going to show you came from the Voyager 1 spacecraft in, I believe it's Valentine's Day of 1999. And this Voyager spacecraft, which didn't land on any planets but flew out into space and is still traveling out into space, well, it was about around Neptune, and we could talk to it, and we said, turn around and let's get some pictures looking back from where it came back to us on Earth. And this is the image, one of them, that it sent back. And that little dot is Earth. And I want you to look at that, and I want you to just realize that is the only place we have ever found life. And that everything that's ever happened that we've ever known about, all the good and the bad, have happened on that little dot. So every person that you've ever known or read about in history, everything from the dinosaurs till now, even things like music and the internet and books and art, all of those things have happened on that little dot. And of course, if you go further out, You see there are lots of other stars. We started off talking about our Milky Way galaxy, which is huge. It has roughly 400 billion stars in it, and it's only one of several billion galaxies that are out there. So I just want to thank everyone for joining us today on our voyage to the planets. We'll likely have more in this series talking about, again, more detail about the planets, but other things like astronauts and black holes and what is it like to live and work in space. If you have any questions, please, you can email them to me, or you can look for things that I'm posting on Twitter about some of the really cool things that are happening right now in space. We've got a lot of new exploration happening with the James Webb Telescope. We've got a probe that is going into the outer reaches of the sun called the Parker Solar Probe. And of course, hopefully keeping our fingers crossed that later this year, the new Artemis system, which is a new spacecraft, is going to be going around the moon for the first time. We'll be sending a vehicle around the moon since 1972. So thank you for joining me. My name is Steve Lang at the Canadian Space Resource Centre at Mark Garneau Collegiate, part of Leadership Learning and School Improvement.